All right, here we're going to talk about your ability to handle both constant velocity and accelerated motion scenarios mashed together. So can you figure out when you got to use one, when you got to use the other? So we're going to focus on that target. All right, so here we got a situation. A runner's trained to get exactly a 5-minute mile. Why exactly 5 minutes? I don't know. But a mile is defined here as 1,609 meters. The runner knows they can only run with a constant speed of 4.2 meters per second. Apparently they do a lot of research. They can then accelerate it to a max speed of 11 meters per second. When they start to accelerate, there's no turning back, and they will accelerate to a constant rate, accelerate at a constant rate all the way through the finish line. So the runner needs to know at what time they need to start accelerating to get exactly a 5-minute mile time. All right, so try the problem, see what you get. I'll show you how I did it, and in about 2 seconds I'll come back with the answer. All right, so I'll see you then. So pause the video, give it a shot, unpause it, see answer. All right, there's your answer. At least that's what I got. At 197.35 second mark, that is when they need to start accelerating. Anything after that, they're not going to make it. Anything before that, they're going to get less than 5 minutes. So that's the exact time at which they have to accelerate. So you might be wondering, how did you do that? Well, I'll give you my step-by-steps onto what I did, and we'll see how it relates to what you did. All right, so here's my first clue. All right, so there's the first thing I did. I drew myself a velocity time graph. I could have written down all the variables in a list, but in all honesty, I think this one's way easier to solve with a velocity time graph. I'll show you how I can use kinematics as well, but I definitely approach the velocity time graph. So I sketched it all out, and I know that the total displacement, or the area under the curve, is going to be 1,609 meters. And I know the total time is 300 seconds, which is 5 minutes. And there's my initial velocity of 4.2, and then there's my max of 11. You see I go at a constant velocity for a while here, constant velocity, and then I accelerate for the second half. All right, so that's all my given. So let's see if you choosing to use this, if you can figure out how to solve everything. All right, so then I'll give you a hint if you can't still figure it out. So pause the video. All right, first hint, constant velocity and acceleration. So you gotta look at this as two separate pieces. All right, so you got a constant velocity part, you know how to use that. You have a constant acceleration part, you know how to deal with those problems. So that's my second hint. And then I'm gonna start breaking it down on how I actually solved it. So give it a shot again, say I do. All right, here's how I solved this using purely graphical methods. So total displacement is equal to this rectangle right here, all right, this rectangle plus this triangle right here. So area on a velocity time graph is displacement. So again, area of a rectangle plus the area of a triangle gives me total displacement. And so I wrote those out in terms of all the variables I knew. So the rectangle is just 4.2 times 300. The triangle, this part right here, is 1/2 base times height. Well, my base is 300 minus t, and my height is 11 minus 4.2. So I have 1/2 base times height. And then here's me simplifying it. You'll notice I only have the one variable of t, so I can solve and I get 197.35. Now, that may not have been your cup of tea. You might have used it kinematics. Well, if you did that, then you would have done this. So here we have a constant velocity portion where we can figure out the first section of displacement because that's this section right here. Then we would have had a kinematics part where we have constant acceleration, so that would be this segment right here. And if you figure out the total equations for displacement and time for those two, smash them together, then you combine that with the total knowledge that the total displacement is 1609. Then it's a matter of substituting and solving. And look, you get the exact same answer. Although the graphical method seems way easier. But either way will get you the exact same answer. So two ways to solve the problem. Both will get you 197.35 seconds. So that's kind of a decent example of how you handle constant velocity and acceleration problems that have been mashed together. So as always, if it was tough for you, watch some vids, try some probs, seek some guidance. Either way, I'll see you in class.